All right, in this example, we're asked to use the second derivative test to classify the critical points as local minima or maxima. So first of all, let's find the critical points. And remember, you always find the critical points by taking the first derivative and setting it equal to 0. Regardless of what test we're using, we always use the first derivative to find the critical points, right? So the first derivative is 4x cubed minus 12x squared. All right, so we're going to set that equal to 0. So I'm going to factor it. Let's factor out a 4x squared, okay? And then we'll be left with, what, x minus 3. All right, and then when we set it equal to 0, you'll see we have critical points at x equals 0. Right? That would make the 4x squared 0 because we have two factors. We have 4x squared, that's 0 when x is 0, and then the x minus 3 is 0 when x equals 3. Okay, so those are our two critical points. So if we want to use the second derivative test, now we're going to take the second derivative and find that. So we get 12x squared minus 24x. All right, now we're going to test these points, but let's go ahead and let's see. Let's go ahead. Let's factor out at 12x. Factor out at 12x, right? And then we'll have x minus 2. So we might as well do that. It might make the calculation easier. So because all we really need to know is whether the second derivative is positive or negative, and sometimes when it's in factored form, that's easier. So now let's test. Let's use a second derivative test. So here's our test. We're going to test the concavity at the critical points. All right. So I'm going to first of all just let's look at f double prime. All right. That's the concavity at 0 is equal to, right? If I plug that in, I get 0. That's not positive or negative. All right. So what does that mean? All right, if the second derivative is 0, then the second derivative test is inconclusive, right? So I'm just going to write inconclusive, right? It doesn't tell us anything. And so that means if we want to test that point, we got to go back to the first derivative test. All right, so let's test the other point though. Let's try to use the second derivative test on the other point, which is 3, right? The second derivative at 3, we're going to get 36 times 1. So that gives us 36, which is greater than 0. So, so we can conclude that it's concave up at x equals 3, right? Concave up looks like that. So it tells us we have a local minimum there. So we have a local minimum at, let me write that down, local minimum at x equals 3. All right. Now, I didn't leave myself enough room here, but we got to use the first derivative test to test the other point. All right. So I'll just write that over here. Use first derivative test for x equals 0, because right now the second derivative test is inconclusive. So let's look at the first derivative at something less than 0. So let's just try a -1. And if we put in -1, right, into the first derivative now, we're going back to the first derivative because we couldn't tell anything from the second derivative test. So we get 4x squared. X is a -1, so when we square it, we'll get a +1. So we have 4 times a -1 minus 3, right? Now, whatever that is, it's less than 0. Okay. Now, what that tells us is that the function is decreasing, right? Because now it's the first derivative, right? And with the first derivative test, we have to test points on either side, right? So the first derivative at a point to the Other side, let's just do 1. We have to do another point to the right of 0. And so if we do that, we'll get 4 times 1 squared, which is 4. And then we have 1 minus 3. And notice that that is also negative. All right. So what does that tell us? The function is decreasing, and then it continues to decrease on the other side of 0. Right? So essentially, that point is neither maximum or minimum. So I'll just say here x equals 0 is neither. All right, now in order to determine that, we had to use the first derivative test on it. All right, because the second derivative is it was inconclusive in this case. So that's one of the issues with the second derivative test is it's not always conclusive. But it can be easier sometimes, especially if it's easy to take the second derivative of the function. Sometimes it's just easier to use the first derivative test because sometimes you have to use product rule or something, and something that makes taking the second derivative harder and uglier. So, but with a polynomial, it's really easy to take the second derivative of it. And then you only have to test the critical points, right? You don't have to test points on either side, right? So there's fewer points to test. It's just that sometimes you run into these cases where it's inconclusive. All right, I'll meet you in the next video for the last example.